So we are trying to find the area between these particular functions, this sine function here and this just flat line, just 1/2. So to plot it out, we'll have our sine in blue. Now this one is basically to 60 degrees, right? So we start off at 0, so you have to remember your unit circle, but this is a calculator assumed question, so I'm just going to explain this and then we're going to dive into the calculator. So we go from 0 to something like pi on 3, and it kind of does this sort of a deal, and then this guy here, this 1/2 is kind of doing something like this. But remember, we don't really need to plot the rest of the function here. So we don't too fussed about the rest of the function. We're only concerned about the stuff inside this this bounding domain here. So normally what we need to do is figure out which function is on top and which one is on the bottom and do the definite integral of that. So you'll have the thing on the bottom, which is the 0, so that's the lower bound here, and you've got this guy here. And the thing on the top is pi on 3. Now remember, pi on 3 is like, that's equal to 3.14 divided by 3. So it's roughly equal to like 1.04, right? So that's all the number. It's just a number, right? Now, normally you have to figure out where they cross and then put the function at the top and then put the function subtracting it at the bottom. But we're lucky because we've got a calculator, we can use the absolute value, which no matter what, always makes it positive. So we could do sine x minus 1/2 and then slap that into the calculator. So that's what we're going to do. Let's bring up this calculator. I first of all want to plot it for you. So then that way you can have a look at what it might look like. So we'll go graph and table. We'll change this to saying sine of x, and we'll plot that one. And we'll say this one here is just 1 divided by 2. And we'll plot that one. For this area, we'll make this briefly, 1.2. I'll OK that, and we'll plot it, and we'll see what happens. And I'll also zoom in a bit. So I'll make something like 2. There we go. So we can see that that 1/2 is on top at the beginning. And then at some point here, it'll cross over. So if I go analysis, G solve intersection, we've got this point here that it intersects. So maybe I can do it as a radian and real. There we go. So now let's take it to our main function. So as before, I was saying that point that they intersect, you'd have to solve for it and then write out 2 equations. So 0 to whatever point they intersect, and then the 1/2 is on the top, so minus the sign. But you don't have to do that if you've got the absolute value. Life is good. And whatever that is, dx. So let's slap this thing here in blue into our main function, and we'll be able to get an answer pretty much straight away. It becomes very, very easy. So let's go menu, main. We will jump into math 2. Yeah, math 2. This is the one here. It's all in terms of x. We'll go from 0, and we'll also make it go from pi. So we need to find pi divided by 3, and we will go absolute value, sine of x minus 1 divided by 2. And if you want to put that in nicely, you can make it 1 divided by 2. Now, the thing that's going to trip you up here is that you've got to set your values in radians because it's in pi, so it is in radians. You've got to have it in real, and I'd recommend having it in standard, unless it spits out a horrible number when we do this. So if I hit enter, that is equal to not a nice number, but that's the best that we're going to get. So it did try and make it standard, not decimal. So it's not nice. It can't quite figure it out. So for this one, you just say use calc and say that this is all equal to, or A for area is equal to 0.2 uh, 232. Perfect. And then that's how you do it. So awesome. Hopefully that explains it all. Remember, make sure you refresh the question, try and do as many as you can. Put pen to paper. That's the only way that you're going to learn.